All right, so you've built a bunch of predictive models. It's super tempting to just look at the scores, pick the highest one, and call it a day, right? But what if I told you that the highest score, well, it doesn't always mean you found the best model for what you're actually trying to do.
Let me ask you a question. Picture a clinic. What's actually worse, missing a real diagnosis and sending a sick person home, or causing a false alarm, telling a healthy person they might be sick? I mean, really think about it. The answer to that question, it changes everything. It's really the core of what we're talking about today.
Okay, so let's get concrete. Here's the mission we're on. We're going to use a pretty well-known data set on PIMA diabetes to build our model. And the business goal? It's simple, but it's so important. We need to flag patients who are at risk of diabetes, but do it earlier. Why? So we can improve their health, their actual lives, and hopefully reduce costs. This goal, that's our North Star. Everything we do has to point back to this. So to tackle this mission, we didn't just train one model. We trained 4 different kinds. You can kind of think of them as 4 different athletes, all competing for the same prize. Let's go to the scoreboard and see how they did. Okay, so take a look at this. At first glance, it's just a total mess, isn't it? I mean, logistic regression wins on a couple of metrics, like AUC and precision. But then, random forest is the king of accuracy and MCC. And wait, don't forget Naive Bayes. It's the champion for F1 and recall. It's like everyone gets a trophy, which is not helpful. And this right here, this is the whole problem. If every model is a winner at something, who's the real winner? How on earth do we pick? If we just stare at the scoreboard, there's no way to declare a clear champion. So how do we break this tie? Which one of these models are we actually going to use in the real world? Well, here's the secret. The answer is, we've been asking the completely wrong question. It's not about finding the best model in some abstract academic sense. It's about finding the best model for our specific mission. And to do that, we have to get a really good handle on what these different scores are actually telling us. So let's start with recall. Sometimes you'll hear it called sensitivity. Honestly, the easiest way to think about it is as the don't miss anyone metric. It answers a simple question. Of all the people who actually have diabetes, how many did our model manage to find? So a high recall score means we're casting a wide net and we're really good at finding the folks we need to find. Now, on the flip side of that, we've got precision. And if recall is don't miss anyone, then precision is the don't cry wolf metric. It asks a different question. Of all the patients our model flagged, how many of them were actually diabetic? So, a high precision means that when our alarm goes off, we can be pretty darn sure it's for a good reason. And this is where it gets really interesting, because this highlights a fundamental trade-off. You see, you can't have it all. You can't just maximize both of these at the same time. If your goal is to leave no one behind, you gotta cast a really wide net to catch everyone. But that means you're gonna accidentally catch some healthy people too. That's high recall, but your precision goes down. But if your goal is to only be right when you sound the alarm, you're going to be way more careful, only flagging the super obvious cases. And that means you're probably going to miss a few. That's high precision, but lower recall. It's a balancing act. Okay, so now that we get this trade-off, we can finally build a real decision framework, something that gives us a clear path from our mission, our business goal, all the way to picking the right model. And here's the big reveal. The aha moment. The answer wasn't hiding in the model's scores at all. It was right there in our mission statement from the very beginning. The choice of which metric matters most, and because of that, which model is best, it's all driven by the real-world decision we need to make. All right, let's play this out with a real scenario. Imagine our job is to run a huge public health screening program. What's the thing that keeps us up at night? It's missing someone. A false alarm, a false positive, that means someone needs a follow-up test, which is an inconvenience. But missing a case, a false negative, that could lead to serious health problems down the line. The cost is just way, way higher. So for a screening mission like this one, our number one priority, our primary metric, has to be recall. We can't afford to miss anyone. So we go back to our messy scoreboard. And who has the highest recall? It's Naive Bayes. Suddenly, it's not confusing at all. For this job, Naive Bayes is the clear winner, no contest. But what happens if we change the context? Let's imagine a totally different scenario. Now, the follow-up tests are super expensive, maybe even invasive, and we have a really tight budget. We simply can't afford to send a bunch of healthy people for these unnecessary procedures. All of a sudden, the cost of a false alarm is the thing that's really high.
Okay, in this world, our main goal is to avoid those costly false alarms. So the metric that we care about the most is precision. We need to be right when we flag someone. So we go back to that same scoreboard one more time. And who's our champion of precision? Logistic regression. For this mission, logistic regression is the undisputed best model. See how that works? So there you have it. 2 totally different missions leading to 2 totally different best models. And it all came from the exact same scoreboard we started with. This idea, it completely changes how you should think about evaluating a model. And if you remember one thing from this, let it be this. The best model is never just the one with the highest number next to its name. It's the one that best supports the real-world decision you're trying to make. Think of it like a tool. You wouldn't use a hammer to saw a piece of wood, right? There's no single best tool. There's only the best tool for the job at hand. And that really brings it all full circle. Remember our mission? It was never about getting a high F1 score or a great AUC. Our mission was to help people, to flag at-risk patients to improve their health. Those numbers on the scoreboard, they're just clues. They're guides that help us pick the model that's going to have the biggest real-world human impact. So I'm going to leave you with a final thought. The next time someone comes up to you all proud and says, "Hey, check out my model, it has 90% accuracy," you'll know exactly what to do. You won't ask how they got that score. You'll look them right in the eye and ask, "That's great, but what's the mission? And is accuracy even the right metric for that mission?" Thanks so much for watching.